This is Britt Caswell with another example video. In today's video, we're covering example 5 from lesson 7-6 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to find a trigonometric model. Okay, so we're going to take a scatter plot of data and try to write the equation for the graph that we see. This one's going to be a little bit of a bear, guys. So remember our general kind of equation. I've been pasting it 6,000 times. Oh, gotta paste it again. So remember our general form of the equation. What we're going to be doing is trying to figure out A, B, C, and D, and then, from there, just fill it in to write the equation. That's kind of the name of the game, okay? So it says, the table shows the average high temperature by month for Washington, D.C. How can these temperatures be modeled using a trigonometric graph? How does the midline value compare to the average of the 12-month temperatures? Okay, so notice the first 12 months they graphed on here. Then they just cut it and pasted it. All right, so that's why there's two bumps with 24 points instead of 12. Now the reason why is because this is not a shape we're used to. That's not it. It's imbalanced. It's ugly. Okay. But within this graph, if we look real close, right there. Do you see it? Do you see that sine curve? That's the name of the game. That's what we're looking for. Okay, so now let's figure some of this out. So the first thing that we want is we want our amplitude, right? We want our A value. So to figure out our A value, what we need to do is we need to know what our maximum is and what our minimum is. So I'm looking at my table of values. 88 looks like the biggest. There's a max. And 43 looks like my minimum. Alright, so to find my amplitude, I'm just going to take the maximum, subtract the minimum, and divide it by 2. Okay? The other way to go about doing that is you find the average between those and then subtract that average from your maximum. Okay? That's the way that I've taught you throughout this. This max minus min divided by 2, I think might be the first time that your textbook shows you that. Thanks, Savvas. So there we go. So I'm doing 88 minus 43 over 2, which is 22.5 for my amplitude. Now that being said, I still want that midline because I want to know exactly what it is because this is asking me about the midline. So I'm going to do the same calculation, but I'm going to do it with a plus. Okay, so my midline is the average of those two. So 88 plus 43 over 2. And so when I do that, my midline is 65.5. Okay, right? If I do 88 minus 65.5, that gets me 22.5. Whatever. Okay, so we'll look at that average and compare it to the midline here in just a minute. But let's finish what we're doing here. Now B is talking about the period. So my period, this thing happened over 12 months, right? Because we had 12 months of data. So remember, the period equals 2 pi divided by B. So since my period is 12, I could solve for B now. Okay? So I just flip my 12 and my B, so my B equals 2 pi divided by 12. And if I reduce that fraction, you get pi over 6. So that's my B value, which is ugly, but okay. Now my C value is our phase shift, remember? So it's how much to the left or right this graph has moved. And so if I look, this iteration of the sine curve that I kind of found within it is at 4. So my C is about 4. And then my D is how much this graph has been moved up or down. My D is that midline. Okay, so 65.5 for my midline. So the function that I would write out, I would say the y equals A, which is 22.5. And then I used the sine function to do this. I'm going to say times the sine of B, which is pi over 6. And then in parentheses, remember you put x minus c, so x minus 4. And then you add to it your d value, so plus 65.5. Oops, not 65 over 5, 65.5. Whew, there we go. Alrighty, so there's our equation, which is hideous. Do we judge it? No, but there it is. That pi doesn't look very pi-y. Okay. And so this is also asking, it says how does the midline function value compare to the average? So how does D relate to the actual average of these expressions? So if I add these together, 43 plus 47 plus 56, all that, and divide it by 12, that's how you take an average, you get 66.7 degrees. And so that's super close to your midline, okay? So the midline of your function should be about the average. If this was a perfect sine curve, your midline would be the average, because this top part and this bottom part should cancel each other out. But what this is saying is where the average is slightly higher than your midline, that's telling you there's a little bit higher value here and a little bit lower value down here. Not a big deal. It's fine. Alright, so we're going to try to do this again in the try it, but now it's dealing with Philadelphia instead of DC. Alright, kind of sucks because Savvas doesn't actually give you like the graph and explanation, but that's okay. We're adults. We can do this. Let's start with A. So to find my A, I'm doing the max minus the min and dividing it by 2. So we need to identify our maximum and our minimum. Let's see. So I see an 87 as my max. And it looks like a 40 for my min. Really? They couldn't even put them in different positions. Judging, but that's okay. So we're going to do 87 minus 40 and then divide that by 2. So let me get out my calculator. So 87 minus 40 and then divided by 2, I get 23.5 for my A. Good, because that's what Savvas got. Awkward. Now my B value, my B is dealing with the period, right, which is 12 equals 2 pi divided by B. So I already did that calculation, so I'm not going to do it again. So my B value is pi over 6 here. All right. So now I need my C value, which is the horizontal shift. Well, that's crud. How would I know? I think we could only know this by graphing it, can't we? Ay, caramba. That's fine. That's fine. You know what we have? We have our friend Desmos. So let me snipping tool a picture of the table, and we'll just fill that in, huh? So what I'm doing is I'm inserting a table with 12 months. Now I'm inserting the values of the points in here. 87, 85, 78. Okay. And so now what I need to do is I need to find out where it is on the graph. Oh, that's kind of hard to see. And so I'm going to be adjusting my x-axis. Let's go from -10 to like 14 maybe. Get that stretched out a bit so you can start to see kind of that sine curve in there. Perhaps I should find my midline to see where this curve starts, right? Because remember on the other one they took this and they copied it and put it. I could do that. Go down to 24. And now I'm just copying those values again so that I get the other points that are on there. I don't know. This seems like it might be the smartest thing to do. So that's what I'm doing. I'm just copying the values again. And see how it's starting to fill in that table for me? $67, $56, and $45. So I just copied that twice. There it is. Now I could see my sine curve in here. It's just figuring out about where it's at. Okay. I'm going to cut and paste this onto my graph just to make my life easier later. We're just going to write on top of it is all. So there's my points. That'll be easier to help me see it. And so if I find my midline, if I find my D, I shouldn't have pasted this in here because I'm going to put that midline on there. So if I calculate my D value before I find my C value, that's going to help me to find out where that sine curve starts. Because, you know, depending on where my midline is, it could be this point or here or here. They made it pretty obvious that it'll be around here somewhere. But I want to confirm it. So remember, to find your midline, you're going to take your maximum and add your minimum and divide by 2. So you're just taking the average there. Okay, so 87 plus 40 divided by 2 is 63.5. And so if I go onto my Desmos graph, I'm going to start just another line and put y equals 63.5. You could see kind of where I was thinking on it. Oh, I want to include that. So that's how I'm telling myself where I need to start looking for my sine curve. So how many points over is that to make that sine curve? And I'm going to highlight that in yellow. It's this right here. That's what I'm writing the equation for. Okay. I just can't draw. So it looks like 1, 2, 3, 4. So that looks like my C value here is 4 because I moved 4 points to the right to get that curve going. So I have A, B, C, and D. So I think I'm good. I think I can write the equation out, right? I don't really have much room for it. I'm going to write it over here. So y equals A, which was 23.5, times the sine of B, which is pi over 6, times x minus c, which is 4, which I could have guessed that it was going to be 4 since your max and min were in the same positions. I had the feeling they just changed some numbers, which is fine. We don't judge them much. So there's our equation that we kind of got from it. And then to compare the midlines to the averages, the average of this data is 64.7. So the average again is slightly higher than my midline. So that's a sign that, you know, they're relatively close. Alrighty, so there we have it. That's how to find a trigonometric model. Until next time.